So 2002 paper, question 27 on refraction. Using information from the diagram, show that the refractive index of glass for this red light is 1.52. So your extended refractive index formula contains wavelength, velocity, and also angles of refraction as well. We don't have any speeds here, we don't have any wavelengths, so the only one we can really use is the one with the angles in it. So part A, the refractive index is equal to either sin theta 1 over sin theta 2 or sin theta in air over sin theta in glass. So sin theta in air has got to go on the top, the less dense of the two mediums, so it's sin 20 over sin 13. Remember, the angles must be between the normal and the ray of light. You'll get 1.52. Only one mark for that. Part B, a descriptive question, but only for one mark again. What is meant by the term critical angle? Critical angle is the angle beyond which all light will be internally reflected, or words to that effect. Beyond which all light is internally reflected. That would get you one mark there. You could say it's the angle between the ray of light and the normal at which light striking the glass will be totally internally reflected, or words to that effect anyway. C, calculate the critical angle for the red light in the prism. Well, sin theta of the critical angle is equal to 1 over the refractive index. Remember, that comes from knowing that the critical angle occurs when the refracted ray in air is at 90 degrees to the surface, so that's where the 1 comes from. So that's 1 over 1.52. Sine of that is 41.1 degrees. So that's your critical angle. Sketch a diagram showing the path of the red light until after it leaves the prism. Mark on your diagram the values of all relevant angles. So you need to do a wee bit of calculation here. You already know where it goes when it comes to here. So the first thing I would probably do is figure out what this angle is. So they've got to add up to 180, so that will be 43 degrees in here for that little triangle. You know that you can draw a normal line every time you get at 90 degrees to the surface. These two have got to add up to 90 degrees, so you know that that is 47 degrees here, and that it will be reflected at the same angle that it goes in at. So you're really looking at something like that going in there. This will be 43 degrees, this is 47 degrees, because if it's internally reflected, then the angle of incidence is equal to the angle of reflection. Again, every time it hits the surface, you've got to draw a normal line. You can figure out really what this is. This will be 77 degrees because these have got to add up to 180 in this triangle. That means that that gives you 13 degrees here. So you've only really got one to calculate, and that's the angle at which it emerges at. If you use the same equation as up here, you can figure out that in the less dense medium, i.e. in air, that this will be 20 degrees, and that gives you the full path as it goes through that particular prism. So there's only really one calculation to do, just a wee bit of simple trigonometry as you go through this, and the knowledge that each triangle has to add up to 180 degrees. If this is 13 degrees, following the refractive index formula and putting 13 degrees on the bottom, sin 30, and knowing the refractive index of 1.52, you can figure out that that is 20 degrees. This is reflected here because 47 degrees is greater than the critical angle, which is 41.1. Anytime you're asked to calculate what the critical angle is, chances are you'll probably have to use that when you're drawing a ray diagram. You might have noticed that from the past papers. So it's quite easy to follow the path right through that prism.